Hello everyone and welcome to part 3 of Blood Vessels Explained. Last time we focused on arteries and how they can be categorized into elastic arteries and muscular arteries. We used the right arm as an example and now we will continue what we started. In this lesson you will learn more about capillaries and veins and their journey around the body. So without further ado, let's get started. In the last video, we finished our artery journey at the triceps pollicis artery, which is this artery that goes into the thumb. This artery actually gets smaller and divides into many arterioles, okay? Arterioles. And arterioles are even smaller blood vessels. And this arteriole gets even smaller and we get something called a capillary. To understand what a capillary actually is, let me draw a box and enlarge it so that we can get a better look at these capillaries. And you might be wondering, well, what is this? Well, here is the princeps pollicis artery. And you've heard that name a few times. And capillaries are the blood vessels that directly interact with the cells in our bodies. And therefore, this is where our thumb cells, which are these 3 green blocks, get fed. So if you look at my drawing of the capillary again, you can see the arterioles, which are branching off this princeps pollicis artery. And the capillary actually branches out of the arteriole and interacts with the cells, exchanging its oxygen and nutrients in return for the cell's waste products, such as carbon dioxide. Let me try to draw this out for you. So oxygen and other nutrients exit the capillaries and into the cells. So oxygen plus nutrients. And the cells produce carbon dioxide and other waste products such as urea and lactic acid. And that goes into the blood. So carbon dioxide, urea, and lactic acid. It is at this point that the artery becomes a vein. Not just because it's deoxygenated, but because it's making its way back towards the heart. All the blood from each branch then dumps into a venule, okay, a venule. And a venule is kind of the opposite of an arteriole. And a venule dumps into a vein, okay, which is the opposite of the triceps pollicis. Now we can come out of the box, and we can follow the path of the deoxygenated blood through the radial vein, the brachial vein, the axillary vein, and the subclavian vein, which are all opposites of the arteries we have here, all of which I'll draw in time lapse. So here they are. You might be wondering why I've drawn the veins much larger than the arteries. Well, remember what we've learned in part 1. The artery carries a much lower volume of blood than the veins. For those of you who are fond of statistics, the veins carry 65% of the blood in the body at any given time. Compare this to a mere 15% that the arteries carry, and you'll know what I mean. But the veins don't have high pressure. And this is why they need valves. So let me draw them for you. Valves. And valves are flaps that keep the blood moving in one direction. And so the veins need those valves to push the blood as it sluggishly makes its way to the superior vena cava. And we've talked about the superior vena cava a lot over this heart series. And the superior vena cava is where all the veins in the top half of your body dump into. Okay? So from here, the blood enters the right atrium, and then it enters the right ventricle, and so on. And the cycle starts again. Check out my previous videos for more information on the anatomy of the heart, but this will be a good place to finish this video. So if you've enjoyed it, please subscribe and hit that like button. Bye for now.